All right, radio and radio waves. That's our video today. And when we think of radio, we all think of music, right? Music in our car, talk radio, sports radio. Radio waves, of course, will add to that because they're modulating sound for us to hear on the radio. And what's surprising about radio waves is radio waves are part of the electromagnetic spectrum. Electromagnetic spectrum. And what that means is radio waves are light. It's light we can't see. If we can see radio waves, you would be blinded because all those radio waves that are coming into your room, right? Because radio waves will penetrate walls. So if we have our arrow, bring our arrow down, radio is light. They have the longest waves of light. And then there's microwaves are light. Infrared is light. And then VL, visible light, that's the only light we see. That's light. It's the only ones we think about as light. And then there's ultraviolet. That's light. Can't see ultraviolet. And there's X-ray. Get your X-rays at the dentist. Right? That's light. And gamma. That's light also. So radio has the longest waves of light, and gamma have the shortest waves of light. But the only ones we see again are visible light. Now, snakes, for example, they can see infrared. Snakes, and if you remember the movie Predator, or if you've seen Prey recently, right? The predator sees in infrared and heat visions, like a heat vision. Think of infrared. So snakes can see in infrared. And ultraviolet, well, birds can see in ultraviolet. They can see a lot of colors we can't see. But no animals see micro and radio and X-ray and gamma. No animals, as far as we know so far. But again, just to review, all these that I mentioned, this is part of the electromagnetic spectrum, and all of them are light. And remember, light moves at 186,000 miles per second. All of them are moving that fast. But even though they're moving at the same speed, some have more energy, some have less energy. Radio would have less energy than gamma, more energy. So as you go from the left here, if you're going from the left all the way to the right, the wavelengths get shorter, the energy increases. All right, so here's our wave. Again, I said the longer the wave, the lower the energy. Let's get our pen going. Let's use blue. Why not? Now the wavelength is from one wave to the next wave. And it's usually used the symbol lambda. Lambda. Lambda is the Greek letter. Has that L sound. It means a wavelength. Longer wavelength, lower energy. Higher wavelength, higher energy. Easy to know. So the wavelength also comes to mind frequency. So with frequency, we're talking about the waves per second. So gamma, which has high energy, will have more waves per second. Therefore, they'll have a higher frequency. Where radio has the lowest, they'll have lower waves per second, lower energy. And frequency is measured in hertz. All right. And so in this video, you'll hear about, and we're talking about radio, we'll hear gigahertz. So gigahertz is gigahertz. You'll hear about megahertz and kilohertz and just hertz. So when we're talking about gigahertz, we're talking about 1 billion hertz. 1 billion hertz in a gigahertz. For megahertz, we're talking about 1 million. For kilohertz, 1,000. So let's look at the radio wave hertz. So radio waves go from 30 hertz to about 300 gigahertz. So again, the hertz are telling you the frequency, and the higher the frequency, the more waves per second. So 30 hertz, just to give you an idea, that's about 1 millimeter. But 300, that would be 6,200 miles. So radio waves can travel much further, and radio waves are much longer than any other part of the electromagnetic spectrum. But even within radio waves, some are smaller, some are larger. So let's talk about that. And I have a picture of this old TV. And let's get our pen going. The reason why is because when we're talking about radio, we're not just talking about radio itself, also talking about TV, because TV is part of the radio signals. It's radio waves. So is GPS. They're radio waves. So are your cell phones, for example. Those are radio waves. Baby monitors, radio waves, and so for walkie-talkies. So on the top of this TV, if you remember this, they had this VHF knob, and that was a band. On the bottom, it had this UHF, and I'll explain what that is in a minute if you remember these types. So in radio and TV and GPS, we have either high frequency, very high frequency, ultra high frequency, and then there's super high frequency. This is all under radio. All under radio. So high frequency is listed as AM radio, which you're familiar with, and shortwave. And they used to sell a lot of, and they still do, these radios that where you can have shortwave AM or FM. Now VHF, very high fidelity, that's FM radio. It's also television. Now UHF, that's we're dealing with GPS systems, we're dealing with Bluetooth, cell phone, and so forth. And super high, we're talking about satellites, especially military satellites. So AM radio, we'll talk about first, that's high frequency. VHF is TV and FM radio. And by the way, AM means amplitude modulation. They're modulating the sound for it to travel, same with FM, frequency modulation. So in these old televisions where you can tune into certain channels, you would tune into the VHF channels. And occasionally, maybe you can pick up a UHF station if there was any broadcasting, but they were far and few between, if you remember way back in those days. So when we're talking about AM radio, AM has some, let's put a little box here. Well, let's write it right in the television. Why not? See if we can fit it. So AM, the thing about AM is it will travel farther. AM will travel, AM radio waves will travel much farther, much further, farther than, let's say, VHF or UHF. They'll travel much further. The only drawback here is, I'll put a little arrow here, change the color so we can see that arrow. So AM will travel much further, but again, the longer the wavelength, which AM has a longer wavelength, the longer the wavelength, the less information can be stored. So this is important. So AM radio will travel further than FM radio. But it cannot contain that much information compared to FM. That's why in FM radio the music sounds much better. Simple as that. And there's a limit on distance, so UHF will contain even more information. The only problem is the distance problem. As you go up in these frequencies, the distance gets shorter. All right, let's clear that out. Let's keep that television there. Why not? So when we're dealing with AM radio, we're talking about hertz that can go from 535 kilohertz all the way to 1.7 megahertz. And FM is much higher. FM goes from 88 megahertz. Much more information can be obtained to about 108 megahertz. Now, so FM contains much more information. That's why it sounds better than AM. But AM could travel further. And as we go up in the hertz, more information can be stored, but then we have the travel problem, the distance problem. And by the way, in the TV bands, TV, and again, FM and TV are part of VHF, very high frequency. TV can go from 54, so 54 to about, and depending on the band, so it can go probably up to 220 megahertz. Should use an M instead of an H, right? Megahertz. There we go. And then you get into the UHF range, which about 300 megahertz. The UHF range. 300 to about 3 gigahertz. So again, just to review, UHF can contain much more information than the VHF, but they can't travel as far as the VHF. And none of them can travel as far as AM radio. Another thing to know about AM radio is it'll bounce off the ionosphere. Let me show you the ionosphere. So here's the ionosphere. And the ionosphere is about 190 miles, any between 40 to 190 miles up. It's in the thermosphere. So let's write it down. Let's get the pen. Why don't we use black? Why not? So the ionosphere, guess what it has in it? It has ions. So it's charged. It has free electrons roaming around. And again, it is in the mesosphere. I'm in thermosphere, sorry, the thermosphere, way up there. So what happens is and only AM could bounce off it. Only AM radio will bounce off it. FM radio, any other VHF will go right through it. Whereas AM radio, just the right frequency, it will react with those free electrons. And those free electrons are going to vibrate and they're going to re-radiate the same frequency back. So they're going to re-radiate it back to Earth. And that's another reason why AM has good distance and can go over certain areas like hills and so forth. Now, there are 3 layers, like I said, in the ionosphere. The D layer absorbs a lot of AM radio in the daytime, but at night it disappears. So you can see at night, you're wondering why you can hear certain radio stations at night. Well, there's less traffic, right? There's less radio traffic in the daytime. Also because that D layer disappears. So you can see that these radio waves are bouncing off all over the place. So you can pick up a station from Cleveland, or if you have shortwave, maybe you'll pick up France or China. All right, and here's the layers of the atmosphere. So the ionosphere is on the bottom layer of the thermosphere. It's in the thermosphere. We'll use red. Why not? There it is. And again, the radio waves from our atmosphere, the troposphere, is bouncing off. At night, it bounces better. And so we can get long AM signals. Right, so just a quick review. We know that radio is light. It's part of the electromagnetic spectrum. Radio has the longest wavelengths, from 1 millimeter to 6,000 miles or so. When we're talking about visible light only has, we're talking nanometers. Let me show you visible light, the ones we see. So here's the spectrum that we only see this part of light, the visible light, and we call it visible light for us, but snakes don't see it. So let's get our pen going, right? So we have red over here, red being having the longest wavelength of visible light, 700 nanometers, which is nothing what radio has. And then we have ultraviolet, and we have, no, not ultraviolet, but violet over here. Ultraviolet would be over here. That's why they call it ultraviolet. And by the way, that's why they call it infrared. Infrared, can't really see it, but you understand what I'm saying. So again, we see visible light, but we don't see radio waves, we don't see microwaves, we don't see infrared, we don't see ultraviolet, we don't see X-ray, and we don't see gamma, but they're all light. They're all light energy. They're all part of the electromagnetic spectrum. And again, just to review, the longer the wavelength, the shorter the energy, the lower the energy. High energy, short wavelength. All right, so that is radio.